Welcome back. We've covered a lot of complex and powerful algorithms. Now, let's look at one that is beautifully simple, yet surprisingly effective. K-nearest neighbors, or KNN. So, what is KNN? It's a supervised learning algorithm that operates on a very simple premise. Things that are similar tend to exist in close proximity. To classify a new, unknown data point, KNN simply looks at the k closest data points from the training set, its nearest neighbors, and takes a vote. The new point is assigned to whatever class is most common among those neighbors. The process is incredibly straightforward. First, you have to choose a value for k, the number of neighbors you want to poll. Let's say we choose k equals 5. Then, for a new data point, we calculate its distance to every single point in our training data. We then sort those distances and pick the top 5 closest points. Finally, we look at the labels of those 5 neighbors and assign our new point to the class that shows up most often. The most important decision you have to make when using KNN is choosing the right value for k. It's a classic bias-variance trade-off. If k is too small, your model will be overly sensitive to noise and individual outliers, leading to overfitting. If k is too large, the model might become too generalized and miss the local patterns in the data, leading to underfitting. The biggest strength of KNN is its simplicity. It's easy to understand and implement. It's also known as a lazy learner, because it doesn't really have a training phase, it just stores all the data. The main weaknesses are that it can be very slow when making predictions on large datasets, as it has to calculate so many distances, and its performance is highly dependent on choosing a good k. Despite its simplicity, KNN is very useful. It's a core component of many recommendation systems, used to find users like you. It's also applied in pattern recognition, like identifying handwritten digits by comparing them to a database of known examples, and in finance for finding similar stocks. And that's the beautifully simple idea of k-nearest neighbors. It's a powerful reminder that sometimes, the most intuitive approaches can be incredibly effective. Now that we have a solid library of different algorithms, it's time to bridge the gap from theory to practice. In our next lesson, we will introduce the essential Python library that lets us build all of these models with just a few lines of code. Scikit-Learn.